This is Physics 2212, Lab 2, Lines of Charge. So the purpose of the lab is to determine the amount of excess charge on a piece of tape. We're going to use that data to observe the interaction between a charged object and household items. We're going to treat the tape as a line instead of a point charge like we did in Lab 1, and the purpose is to calculate a better approximation of the amount of charge. So the preview of the results is that our charge is going to be 3 times 0.08 3.08 times 10 to the negative 8, which is very small. So here's some fundamental principles. We have Newton's second law right here. We have Coulomb's law, gravitational force, electric field. We derive the point charge from the electric field. And then we have the electric field of a rod. So this is what we'll mainly be using to calculate the new charge. And then I just derived Q from that. And then the force of gravity will equal force electric, and force electric will be the E rod. So the models and assumptions. So for models, each of the tape was modeled as multiple equal segments along the tape, and these segments were modeled as point charges. This was necessary so we can apply properties to superposition. Some assumptions we made is that air resistant and negligible, and that each piece of U tape has the same charge and it's evenly distributed along the length of this tape. So for the experiment, we had to create 2 U tapes, and one was placed on the table as a base tape, and the other one was placed on top, pulled swiftly away, and done for 2 tapes. And then we observed the motion between the 2 tapes, and we observed the interaction between the U tape and a plastic object. And then we suspended 1 U tape on objects of equal height, and then used another U tape under it and observed that motion as well. So some observations is that the system is going to be the suspended U tape, and the surrounding is the held U tape and Earth. The U tape is positively charged. The interaction between the 2 tapes is repelled, and then the interaction between the U tape and the hand is that they're attracted. And then with the U tape and the pen, also attracted because your hand and the pen, they're both negatively charged, the U tape is positively charged. And then the interaction between the suspended and non-suspended U tape is also repelled. So some data that we have is that the mass is there. We have the mass of the tape, the distance between the suspended and non-suspended tape, and the length of the tape. So here's my computational model. So here's all that information that we had before. This is the mass of the tape. This is Q, which we calculated using the E rod formula. Right over here, we calculated the electric field, and then we chose the scaling factor, and then we have the force electric on top. This just kind of creates the model and initializes a few properties for the for loop, where it's going to iterate through the loop, and then it's going to calculate the E field and all the derivations over here, calculates the electric field at the location of dq of the top tape due to the bottom, and then it calculates the electric field on the top due to the bottom as it calculates the location and the electric field. And it goes through the for loop, and it's going to keep going for each individual dq, each individual point charge along the tape, so it creates a line charge. And then this is what our computational model looks like. So it tells us the magnitude of electric force and the magnitude of electric gravitation, or magnitude of gravitational force. So the chart, as we saw, the charge of the tape was right over here, which we calculated using E rod. And because the net force was 0 and the tapes are the same charge, the suspended U tape was able to float. That means we're in static equilibrium, and that also means that the force of the gravity is equal to the force electric. So some possible source of error is that there was inaccurate measurement of the tape length, inaccurate measurement between the separations of the tapes, and maybe there were some unequal charges on each of the tapes as it was pulled off the base tape. Some charges may have been lost while handling it, and there was some error of rounding during calculations. So what if you had modeled each of your tapes as a single point charge like in the previous lab? Well, in the previous lab, our point charge was right over here, and then we have our line charge. So as you can see, our line charge is greater than our point charge. So why do these estimates differ? Which value is most likely to be close to real value and why? So the charge is uniformly distributed along the line of tape instead of a point charge. So the line charge is considers the length of the tape and the distance from the observation point. So while the point charge just considers the length of the tape. So the line charge value is actually closer to the real value. Um, it models the charge distribution on the tape better than the point charge does, and the rod-like structure of the tape best fits for the line charge. Thank you.